Lesson 18 is going to continue with the multi-digit division and estimating quotients. The first problem that we're going to take a look at is 8,095 divided by 23. Step 1 is still identify the whole and the divisor. The whole is that big number that we're dividing into smaller parts, which is our divisor. So my whole is 8,095. And my divisor is 23. Step 2 is we want to round the divisor. So we take a look at here and we are rounding to the tens. So on my number line, my bottom 10, I would either be rounding down to 20 or I would be rounding up to the next 10, which is 30. My midpoint is 25, and so I would ask myself, where on this line does my divisor fall? And it falls below the 25, so that means I'm rounding down to 20. So I can go ahead and write that in my new equation. So I have my 20 here, and I'm going to have my whole number rounded there, division, and my equal sign. Step 3 is now that we want to round the whole, or this 8,095, to a multiple of the new divisor, which is 20 here. And we're going to think about it in a different way. And the first step to do that is to rename the whole. When we rename, remember, we want to say the value and then what place value that's in. And so here I'm going to start with 8,000, and I got that from the 8 here, and the 8 is in the thousands place. Step 2 is we want to find a close multiple of the divisor's first digit, and our divisor's first digit is 2, so we're going to be doing multiples of 2. And multiples of 2 would look like 2 times 1 equals 2. And we would continue on down multiplying by 2, which would equal 4. Then we move to 2 times 3, which is 6. And 2 times 4 is 8. And I'm going to stop here and go back to what I've done. So these numbers here are my multiples of 2, which I got from relating it back to that first digit in my divisor. See, I did 2, 2, 2, 2. I'm stopping here because I can now say 8. Can I put this 8 into the 8,000? And I can. So I know that this 2 from this 20 is going to be able to go into this 8, or this 8 is going to be able to be divided by this 2. So I found my close multiple, which is 8. So now that I know that 8,000 is a multiple of 20, I can write that number in standard form into my equation. So now I have my new equation with my rounded whole and my rounded divisor. Now I'm ready to solve. First, I want to decompose my divisor into a kind of divide by tens rule. So I would ask myself, what multiple of 10, or power of 10, could I divide 20 into? And I see right away that my 20 is in my tens column, so I could pull out that 10, and I know that 10 times 2 is equal to 20. So I can use these two numbers to rewrite my equation, which is the step 2. So I bring down that 8,000, and I stick in my division symbols. So I've rewritten it as 8,000 divided by 10 and then divided by 2. And now I want to solve using PEMDAS, meaning I start on the left side equation and work my way over. So 8,000 divided by 10, I know that when I'm dividing by tens, I can move my decimal to the left, 1, making my new number, my quotient, 800. And then I can divide by 2. And I can start here. 8 can be divided by 2, which would equal 4. And then I do 2 cannot go into 0. And then again, 2 cannot go into that 0. So my estimate is 400. All right, so let's try this with another equation. 2,691 divided by 48. First, we want to identify the whole in the divisor. My whole is that big number that we're dividing into a certain amount of groups. So my whole is 2,691, and we're dividing it into 48, or my divisor. Next, we want to round our divisor. And our divisor is 48, and if we think about that on a number line, we would either be rounding down to 40, or we would be rounding up to 50. And my midpoint is 45. And so I'd ask myself, where does 48 fall? Above or below 45? 48 is above, so we're rounding up to 50. And now I need to find my rounded whole. And in this case, we're going to take a look here, and we're going to have a couple different options. We want to round the whole to a divisor of 50, and in order to do that, we're going to take a look at the 5, and we're going to be looking for multiples of 5 because that's the first number in the divisor. And so we want to kind of rename the whole, taking a look at that 5. I could do 2,000. But when I ask myself, does 5 go into 2, or can 2 be divided by 5? And the answer is not using a whole number, so I don't want to use the 2,000 renaming. So then I would move to my next column over, which would be hundreds, and I have hundreds here. I would take those first two numbers, 2 and 6, and I would rename 2,691 to 2,000. And now I ask myself, could I divide 26 by 5? Not a clean number, but it's much closer than 2 from that 2,000. So I'm going to go with 2,600. So next I want to find the multiples of 5. So I would do 5 times 1. And if we know, we can just count out our 5s if we feel comfortable enough to do that. We can do 5 times 2 is 10. 5 times 3 is 15. 5 times 4 is 20. 5 times 5 is 25. 5 times 6 is 30. I'm going to stop here because looking back at what I want to go into, 2,600, I have two options here, 25 and 30, one below and one above. And I could ask myself, which one do I want to use? Do I want to use 25 or 30? Because for me, 26 is closest to 25. I'm going to use 25. but I could also use 30. And you have to remember, this isn't 25, this is 2,500. Okay, so you would rewrite it as 2,500, and with hundreds we add 2 zeros. Okay, so my new equation here is 2,500 divided by 50, and now I'm going to solve using patterns of 10. So I take a look at my divisor, and I'm going to decompose that into a power of 10. It's in the tens place value, so I'm going to pull that out, and I know that 10 times 5 would equal 50. I'll drop down my 2,500 and add in my division signs, which gives me my new equation. Then I'm going to solve using PEMDAS. So the first equation that I'm going to do is 2,500 divided by 10, and I know that I can move my decimal over when I'm dividing by powers of 10. So my new number is 250, and then we're dividing that by 5. And now here is where you want to be careful. Okay, you have to ask yourself, you have to start here and say, can 5 go into 2? No. So we have to move over here to the 25, and we have to say, okay, now can 5 go into 25? And then you ask yourself, how many times can it go in? And we know that 5 can go into 25 5 times. And then we ask ourselves, can 5 go into 0? The answer is 0 times. So my answer, or my estimation for my equation, is 50.